Hey guys, so today we'll be looking at a continuation of where we stopped yesterday. So yesterday we saw how do I write a basic equation with all of the formulae, right? From words we came to all the formulae for every compound that's there in a reaction. So for today I'm going to show you how do I make sure the equation is completely correct in sense of being balanced, okay? Now what is this balance? Generally when you add two things, once they add, the resultant whatever you get has the mass or weight of both the objects combined, right? For example, if I add 1 kilo of sand to 1 kilo of say cement, what I'm going to be left with is 2 kilos of whatever mixture that I get, right? So it won't be less than 2, it won't be more than 2 also. Right, so this is called as law of conservation of mass, that says that any form of interaction between matter like a chemical reaction should have equal mass on both sides. So if the reactants are a certain weight, the products also should be a certain amount of weight. Okay. So that is why what we are going to do today, I'm going to show you how do I make sure my equation is balanced by using this question. Now this question is one of the reactions we saw on the first class of this chapter, where we showed you the white colored precipitate, right? Barium chloride, sodium sulfate, the one with the two beakers. Okay. So I won't show the part that I did yesterday, which is writing the formulae. Since I know the formulae, I'm going to write them straight. I encourage you to try crisscross and figure out the formulae for each of these on your own. Okay. So I know that barium chloride is BaCl2. Okay. Again, remember 2 only is for chlorine, not for barium. Plus sodium sulfate. I know sodium sulfate is Na2SO4. Okay, gives, so that is barium sulfate, which is Ba and SO4, and sodium chloride NaCl. Right, this is the basic equation, or what we call as skeleton equation. Now to balance this, the first thing I do is figure out which elements are there in the whole equation. Okay, the same elements will be on both the sides. Now for example, barium, Ba, something you learned last year, the name of a few elements, right? One of those is barium. Okay, so you see barium is on both of these sides. So the first thing I'll do is write barium over here. Now notice there is another thing, chlorine. Chlorine is here, chlorine is there also. So I am going to write chlorine also. Okay. Next is sodium, which is Na. On both sides Na is available. So great. Next, sulfate is not an element, it's a compound. Okay, means it has two different elements in it. Like I said, if it's two capital letters, there are two different elements. So S is separate, O is separate. S is sulfur over here and over here, and O is separate, which is oxygen. Okay, so total there are 5 elements present in the entire equation. Now the next thing I'll do is make like a table wherein I list down how much of each element is present on both the sides. Okay, so this would be my left hand side, which we call reactants, right hand side which is products. Okay, so reactants and products. . Now, for finding out, you figure out which number is attached below the number, the subscript. Okay, for example, barium has no number, and like we saw in balancing, no number means it is 1. So I can say on the left side, barium has only 1 on the reactant side. Same way on the product side, barium again has no number in front of it, right? So I will say it is again 1. Understood? Now chlorine over here on the other hand, Cl has a small 2 over here. So on this side, chlorine is 2. Now product side, chlorine has no number, which means chlorine is 1. Okay. Next comes Na, which is sodium. Sodium over here it has a 2, right? So I will say 2, and right side Na again has no number, which means 1. Now sulfur, S has no number again in front of it. If there is no bracket, this number is only for O. Okay, so S has no number, which is only 1. Again over here S has no number, which is 1. Oxygen finally 4 over here, 4 over here. Cool. Now notice that some of these are equal on both sides, some of these are not. If I check barium, it is equal on both sides, 1 and 1. Chlorine, however, is not. There is 2 on one side, only 1 on the other side. Same goes for Na, not balanced. Sulfur is balanced, oxygen is also balanced. So now I need to understand how do I balance what is not balanced. Okay, so I know sodium and chlorine need to be balanced. Next step is figuring out where the chemicals are less or where the elements are lesser. Okay, now it's very clear that right side is less, right? Because there is only 1 on the right side. Okay, so I figured out where my sodium and chlorine are less, which is the product side. Okay. The next thing I'll do is, how do I make sure that they become equal? So over here we cannot change any of these numbers. Okay, notice that these numbers have to be as it is. You cannot change those numbers. What I can do is change somehow by multiplying. Okay. For example, if I multiply 1 with 2, it will become 2, right? So because 1 into 2 is nothing but 2. Same way 1 into 2 is nothing but 2. Now, so what I can do, I will write BaCl2 plus Na2SO4 gives rise to BaSO4 plus NaCl. Alright, let me write this down because there is no space. Okay, plus NaCl. Now what I can do, I can add a number before the name of a compound. Okay, this is one compound. Each of these is a separate compound. In front of them, if I put a number, it means I am multiplying everything in that compound with that number. For example, if I put 2 BaCl, it means there are now 2 into 1, which is 2 bariums, and 2 into 2, which is 4 chlorine, just as an example. Okay. Now I know that I want sodium and chlorine on right side to be multiplied with 2. For me, luckily both of them are in the same compound, only one called NaCl. So what I'll do, I will write a small 2 in front of NaCl. Okay. Now this sodium now has become 2 into 1, which is 2. Okay, so in a way, once I write this 2 over here, let me just put this plus here, because of this 2, now this has become 1 into 2, which is nothing but as 2. Same way, even this chlorine, 2 ones are, it has become 2. Okay, so now that means that both of these are also balanced. Now if you see, every single chemical, every single element over here is balanced on the left side and on the right side. So this is my final equation. Okay, now I can write it like this: BaCl2 plus Na2SO4 gives rise to BaSO4 plus 2 NaCl. One nifty little way to understand this is, if you know, in math we say x plus x equals to 2x, right? We can write like this, 2 into x, right? Which is basically multiplying x with 2. A way to see this 2 NaCl is like this: NaCl plus NaCl. Can I write that as 2 into NaCl? If I consider them like x, right? So essentially it is the same. So if I write it as Na plus Na, again it is 2Na, Cl is 2Cl, right? So I can simply say 2 NaCl. Okay, either way you understand it, it's the same, because the answer will be balanced once we have this multiplication present in front of the element. Great. So this is all about balancing equations. Just to run over the whole process again: write the base equation, skeleton equation, figure out what elements are there, make a list, then measure the elements on both the sides. Make sure you're checking the numbers properly for which side is for these subscripts. Then figure out which ones are not balanced. Okay, if in our case sodium and chlorine were not balanced on right side, they were less. Now to increase that, we multiply it with some number. So since it was 1, I multiplied it with 2, because 2 ones are 2. So now if I check over here, Na is 2, 2 into Na, which is again 2Na. Okay, right, that is it for today. Balancing, we are going to practice this a bit more and the questions. Thank you.